We're not live yet. Sorry. There we go. We're live. So let's start with the first one, the part two of the group assignment. So there's only two questions, so that makes it nice.
Okay. I'm sorry, give
You
me a
guys,
second because it froze on me. Hold on.
okay. Clayton, are you okay?
I could still hear you guys. I can't like do anything with my browser.
Ah,
Almost there. Did he get logged out?
I'm fine. Is everyone okay?
Yeah.
Okay, cool. Veronica, you okay?
Yes.
All right, cool. So let's start with the first question. It says a four-sided die has four possible outcomes for each roll, 1, 2, 3, or 4. Calculate the mean of this discrete random variable. So,
It's
what did you guys do to get that?
Well, so each value is in sequence, I guess. Like basically, one is worth one and two is worth two, so it's one, two, three, and four, and each you have a probability of getting 1/4 or 0.25 or a point two, or I mean 25% chance of getting each. So basically, to get the mean, we would multiply each value by the probability of getting that value. So the first one would be 1 times 0.25, 2 times 2 times 0.25, 3, and so on, and then you add those
Hmm.
together, and I got 2.5.
Yep, I got that too.
yeah.
Veronica, did you get that too?
Yes.
Awesome.
Yeah.
Next question. Calculate the standard deviation of this discrete random variable.
Isn't it just half of it?
Veronica, sorry?
Well, I was looking at the pattern like whenever I was reading in the text,
Hmm.
and it because of the situation, it ends up being half of that. So I know it's 1.25, but I know that the way to do it is we get the sum and how is it? It's that we get the well, I guess the 1/4 or the 0.25. We minus it minus the sum, the 2.5. Yeah, is that right? That you minus it or you add it?
You subtract the value
Yeah.
from 2.5, the mean, and then you
Then you
square
square it,
it.
and
Yeah.
then you multiply it by the probability of it, and you end up with the. Then you
Did you
do the square
say
root and the
divide or
distribution.
multiply?
Huh?
Did you say divide or multiply?
No, you multiply.
Okay, yeah, that's it.
Yeah.
Multiply by the probability.
Yes. And
Hmm.
then you square root it.
Exactly, yeah. Yeah, that was the last part that got me hung up because I went through the whole thing and I was like, oh yeah, it's 1.25, but there's one more step. You had to square root that,
Yeah.
which was 1.118.
Yeah.
Yes.
Did you guys get that?
Yes.
Yes.
Awesome. So I think we're ready to start the test.
Okay. Oh no.
Okay, so
Let's start doing.
Sorry,
okay, I'm
guys.
starting now.
Being slow. Okay.
I'm all frozen up, so just one second.
Okay, so we have 13 questions. First two are the same as always. Um,
I think. Oh,
Hmm.
come on.
Hang on just one second. Sorry, I wasn't
It's okay. I'm not ready
quite ready.
either.
So, let me sign in here.
Hello?
He logged back in, but did he log out?
I don't know. I can't tell because it like freezes on me, but I can still hear you guys.
Yeah. I mean, I can see you, but in that little window thing, I can't see either of you.
I can't. I see you on the big screen, but I don't see him at all.
Hmm.
I think he got logged out. Or it looks like he's kind of there, but just dark, huh?
Yeah.
You know what? Is it okay if I'm gonna go really quick to get my calculator?
Yeah, go right ahead.
Okay. Okay, is he back yet or no?
I think he's just now logging on. There he is.
Having trouble. I had to come to my niece's room because we have the net.
Oh, yeah.
Hello?
Can you hear me?
Yes.
You guys
All
ready?
right, cool. I'm back. Sorry.
Okay.
I could hear you guys talking, but you couldn't hear me, and it was kind of funny. But and then it logged me out. So
Hmm.
you guys were like, did you get logged out? It's like, not yet. I can hear you.
No, we're
And then
still
we had to
here.
get logged out.
Well, we saw
Cool.
your little window thing, but we could not see your face, so we assumed that you were kind of still logged on, but something happened, and something just happened.
Again.
Okay, let's just give it a minute, and then if not, we'll just continue without him. So
Well, he can do the
because
group chat.
since we're starting late, we are biting on time a bit, just in case we run into difficulties. And he is constant. I mean, he has to turn it in, and right now he's constantly logging out. So
Yeah. Okay, let's get on with it.
time.
I wonder if he can like send a message. Let me see if it works.
What were you saying?
I was like, if we could at least get him to message, I think you can. I think he has to do that.
He's breaking up a bit.
It says he left the group.
Okay, so for now, let's go ahead and continue on. And
Okay.
when he joins us, we'll give him the answer and probably describe it to him what is going on. So
Okay.
note, give all, or number 3,
Mhm.
note, give all your probability answers as decimals. For example, 0.1234. Do not give probability answers as percents. Human blood can be classified into one of our basic types O, A, B, and AB. The proportion of people in the population of the United States with each of these blood types is summarized in the following table. Use this data to answer the following questions. The blood types and the proportions given in the table above define the probability distribution.
That's true, right?
Hold up. Blood types and the proportions given in the table above define probability distribution. Let's see. What's probably? Oh, okay. Basically probability patterns, I'm guessing. Is
Yeah.
that right?
Yeah, I think so.
So, I guess. I mean, it's true.
Yeah, I don't see. Yeah.
What is the probability that a randomly selected person in the United States has the type O blood? So I guess 0.45.
Yeah. Yeah.
Sorry. Oh, he's back.
Oh,
Hey.
okay. I was reading the first question, and I think it is. Let's see. 0.45. Let me just add it up real quick. It has to add up to 1 for it to be true. And if it doesn't add up
right.
to 1,
Okay, so I have that's what I haven't even completely looked through the samples yet. But yes, that does look like it would be. Oh no.
I think it would be true. Yes, it does add up to 1. I'm just being slow with my
Okay.
calculator here.
Yeah, it does.
Yeah.
So I believe the answer is true.
I put true for a different reason. I mean, but yeah, your reason is correct. So we went over 4, and I think it's 0.45. Oh, and just is he there? Oh, no. So when he comes back, I'll let him know about how we're supposed to input it into decimals. Okay, never mind. So let's go ahead to number 5. What is the probability that a randomly selected person will not have type O blood and round to 2 decimal places? So that would be 0. Let's see, 55.
Yeah. But don't you have to divide it? Not divide it, make it a fraction.
No.
Or no? No, because it's
No,
decimals,
remember,
right?
it says, note, give all your probability answers as decimals. For example, 0.1234. Do not give probability answers as percent. So, yeah, we're not supposed to do percents.
Oh, okay. Yeah, yeah. Got it. So it's 0.55, right?
Okay.
Is that correct?
Sorry?
Oh, it looks like he says he can still hear us. Did you see that?
Well, I saw his window
Again.
blink on and off. It's coming on right now. Logging in.
Yeah. Okay. So for number 5, it was 0.55, right?
Well, make sure you put the 0 just in case. 0.55.
Well, yeah.
Because it might recognize the specific answer. Sometimes
Okay.
I mean, when it comes to stuff like this, it doesn't.
I'll read the next one. Okay, I'll read the next one.
Okay.
Is that okay?
Yeah.
Okay. Is it Caroline? No,
Carol.
Caroline Wills and her colleagues conducted a study in which dogs are trained to detect bladder cancer. The dogs were trained to lie down next to the specimen derived from a bladder cancer patient. Tangle, one of the dogs, demonstrated the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. Answer the following questions. If the dog guesses at random, what is the probability that they will correctly identify the dish containing the specimen with the bladder cancer patient? Round
Okay,
2,
so
answer 2.
divided by 7, that is 0.143 because we round it. Did you get the same?
I'm sorry?
Oh, sorry, I didn't give you enough time.
It was 6 samples or 7 samples?
It said, it said 7 bowls containing.
Oh,
So 6 of the samples did not have bladder cancer. So basically, it's 1 in 7
yeah.
bowls. So 1 divided by 7 should be it.
It's 0.143?
Yeah. Again, make sure you put the 0 in front of the decimal because it might not recognize the answer.
Oh, that's right.
Sometimes online homework is specific. Sometimes it has a small range, and sometimes it doesn't matter if you put the 0 in front or not. But usually, I would just say
Put it. All right, thanks.
Oh, so Kevin, we're on number 6. Where are you now? Oh, I think it froze.
Yeah.
Or his.
If you can hear us, Kevin, just chat with us at least.
Well, just put up a message on the group chat board if you can hear us. Okay, so I'm seeing no change. So let's go ahead to number 7.
Okay.
In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? There is little evidence that dogs can detect bladder cancer. This proves strong evidence that dogs can detect bladder cancer. So let's see, rereading it, in a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patients 22 times.
I think it's little evidence.
I don't know. I mean, because basically that is lower than half, but I don't know if that is considered strong enough evidence.
Yeah, that's true. I just reread that because it says it's very unlikely that the dog would do this well by random choice alone. So does that mean that it's more of a probability that they'll get it right? I don't know if it really provides strong evidence, but
If you're talking about probability, I think if you're talking about probability, it'll be the first one.
that one's hard.
That one's a bit.
Why don't we skip that one and we'll come back to it?
For now, I'm just going to put the first answer, but yeah, we can come back to number 7. Go ahead.
You read it backwards.
Huh?
What's your first answer? Because when you read it different.
No, I mean I just reread 7. So I did put the first answer to it. There is little evidence.
See,
Um,
it's not the first answer, it's the second answer.
oh, it might be different for you for some
Yeah.
reason. Sometimes it mixes around.
Yeah.
There is little evidence that dogs can detect bladder cancer. Um, Personally, I would think it would be strong enough, at least to retest. Um, but yeah, for probability's sake, I would say that there is little evidence, I guess.
Yeah.
I don't know. That's kind of a bit of a trick question.
Yeah,
It really
it is.
depends. Um, so, hold on, let me check. Okay. Oh, see if you can invite me to join the Hangout. Okay, so let's pause for a moment. Um, do you know how to invite?
Let me see if I can figure it out. I think there is a way right here. I remember seeing on the side. Let me see. Oh, this thing's not. Oh, there we go. Chat. Showcase. Capture. Control. Give me 1 second. I'm trying to see where. Oh. The thing is that who's the one that's in charge of it? It's him, right? He's
Oh,
the one
yeah,
that invites us?
Kevin.
Yeah, that's weird that we're on and he's off.
Um, well, it's probably set up that way so that it doesn't log everybody out in case. I think that the only terms it would completely log out is if everybody did. So, I don't know.
I'm trying to see if I can
Have
figure
you?
it out.
Oh, so you haven't figured out.
No, I haven't found anything that tells you otherwise, yeah?
Hmm.
You know, it has like menus on the sides. It's weird. I try to click on him, but it doesn't do anything either. Oh wait, hold on, there's one I didn't see. Let's see what it does. Um,
Hmm.